Hello guys again. In this session we will learn how to model a bridge, an girder bridge from A to Z using our advanced parametric families. So to do that we will start by opening a new project using our template, our metric template. At first we have to load all the families that we created in other sessions. We will go to the folder where we have these families and we will start loading these families one by one in order to have all these families in our file. This is the barrier, this is the girder, this one will be used in the pier creation, the pile cap for the foundation and the cap beam for the pier. We can start by creating a grid for the alignment, and we go to structural palette to place the abutment component. We have to choose here abutment. We can press on space key to rotate this component. We place it exactly aligned with the grid. Now we can go to the site plan in order to put the bearing. We can press on WF or go to make it wireframe from the setting. Let us put this dimension to equidistant our bearing, so we can make this dimension equal. Now we can go to the elevation and press on WF on the keyboard or going to display option to make it wireframe. We select the bearing and we move it to be at the top seat of the abutment. We can create a reference plane at a distance of 1.25 meters from the edge to locate the first bearing and the last one. Let us adjust the position of this bearing using SI snap setting. By pressing SI on the keyboard we can locate this bearing. Then we press on array using to last method from this point, pressing on SI to this point. Let us put the dimensions between the bearings. So we have to increase the number of bearings to be 6. Now we have this distribution of bearings with a distance of 2.5 meters. From the edge here we have 1.25 meters. We can visualize what we did for now. We have the abutment and the bearings. We can go back to the site. We have to place the first grid from the left, which is for the abutment 1. We can name it abutment 1 or A1. Now let us copy this grid to the right for a distance of 20 meters. Maybe it's better to be 25 meters for our example or exercise. Now let us delete these two reference planes. I will create new reference planes for a distance of 5 meters to the both sides to locate the columns. I will create structural column and use the circular section that we loaded Let us put it here as height to unconnected value, and we can place this column at the grid here, and we can select the column and copy it to the other side. We can visualize what we have. Let us go to the site plan, then to the elevation. If we select the abutment, we can notice that the super elevation is 50 millimeters. So it's okay to be 50. I will place a slope at the top seat of the abutment. Then I will go to the site plan. I will create two reference planes to get the both edges of the bridge. Let the offset to be 7.5 meters. Then I will draw the cap beam of the pier. So now we have to adjust the columns. We can select the two columns and adjust the base offset to be -5 meters. Maybe it's better to be -8. We can copy this level to the bottom of the abutment. So now we have the bottom of the bridge. Then we select the cap beam and we need to move it to the top. We have to remove constraint and make a check on this join and move it at this distance. Now if we go to the elevation, we can create a dimension between the top of the column and the bottom of the pile cap to know how to adjust our top offset of column. We can press on SI to get the dimension. So the dimension is 1.69. We select the column, we put equal at the first, and we can put here -1.6 meters. Then we can select the second column and make the same offset, -1.6 meters. And now we have the abutment, the columns, and the pier cap. Now let's put the slope on the cap beam as well as on the abutment seat. And what we need now, we need to adjust the cap beam to be with the same slope as the abutment. Let us put the slope again because we lost the dimension. Then we select the cap beam and we find the parameter for the super elevation, which is the start level offset, and we can make it 50 millimeters. Now we can notice that we have the same slope similar to the abutment. Now let us create a reference plane to locate the bearings over the cap beam. we have to adjust the reference plane location to have the bearings equidistant. So let us draw it again from center to center to be in the correct position. We select the bearings, then we copy the bearings from this reference plane to this reference planes. Then we go to the elevation to be sure that the bearings are in the correct location. Maybe we have to create this section in the plan, then make the view wireframe, and we select all the bearings and we move them from the bottom to the top of cap beam. Then we select all these bearings and we press on mirror about the axes to have them from the other side, and then we select the abutment and all bearings and we can mirror this abutment to the other side. So now we have the two abutments and the pier. And now what we need to do is to place the pile caps. We go to structural palette and we choose component, then we select the pile cap family and we place it near the abutment. We need to be sure about the dimensions that we need for this pile cap, so let us put the width and the depth of the abutment. Then we can move the pile cap to the abutment place. We have to adjust the level of this pile cap. We can move it with this join to the bottom of the abutment. We can select this pile cap again, and from the properties we can adjust the bottom offset, and we have to adjust the thickness of the foundation to be well located under the abutment. Then we select this pile cap and we press on mirror to have it to the other side of the bridge for the second abutment. Then we can copy this pile cap to be under the pier. And that's it. So now we have the pile caps for the abutments and for the pier. We need to note that these pile caps are parametric. We can adjust them and modify the parameters as per our design. Now we need to create the girders. So what we have to do, we have to go to structural beam and select the I girder. Then place this girder from bearing to bearing. We can adjust the beam from the end a little bit. Then we go to 3D view, we select the girder and we move it to the top. Now it's better to go to site plan and create a section along the girder. Then we go to this section, we select the girder and we move it down to be exactly at the top of the bearing. So we need it to be accurate. That's it. Now we have to make a certain inclination in the girder to be at the end over the bearing on the pier. So we need this dimension. We select the girder and the end level we can write equal, and we can add this dimension and apply. Definitely the dimension will be deleted. So now we have the girder inclined and it is located exactly over the bearings. Now from the site plan I will select the section, I will flip it, then I will reduce the range of this section, then I go to the section itself and I will select the girder and copy this girder from bearing to bearing. From this bearing to this bearing, I can press on the keyboard on SM to adjust the snap setting. Then I can copy the girder using multiple copy option to have all these girders over all these bearings. So now we have all the girders together. We can go to the plan, then we can select these girders and using mirror option to have them exactly from the other side. Now let us visualize what we have for now. We have the abutments, the pier and the girders. Always we have to visualize our model to be sure that everything is correct. Now we have to go to site plan and we will create the deck using a floor element. We will use a section of 300 millimeters and we can draw a rectangle at the location of this deck from the abutment corner to the bottom side of the pier cap. Then we align these edges to be correct. We go to 3D view to see the location of this deck. I think here we need to adjust the back wall height. We select the abutment and from the back wall parameter let us increase this value to be, for example, 1750 millimeters, and we do the same thing for the other abutment. Now we can move this deck to be exactly aligned with the top of our back wall from this side. And now we have to adjust other edges to have the deck exactly inclined over the girder. So to do that we need to use modify sub element, and now we can start modifying these edges elevation in a way to have the deck exactly aligned with the girders. Now let us create a longitudinal section for the bridge. Then we go to the section, we adjust the crop. We need this section to be exactly at the girder. For this reason, I go to the site plan. I will select the section and move it to the girder location. Then go to view. Now we need to draw a line with a certain offset from the girder. We can isolate this line and the deck. Then we put a dimension to know the value that we need to apply for the deck. Then we go to 3D view and we select and isolate this deck, then modify sub-element. Then we can adjust this offset with the needed value by selecting the two nodes. And we can add this value for these two nodes. Now we go to the site plan and we go back to the section to see what we have here. So we still have these 18 millimeters. We can adjust it like that. So now we have the deck placed correctly over the girders. We select the deck, we go to the site plan and we press on mirror to have it from the other side. Now we need to create the approach slab. We can adjust the corbel of the abutment to be at 400 millimeters. Then we go to the site plan and we create a floor with the same thickness of the deck, for example 300 millimeter, and we draw a rectangle at this location. We can adjust the location of the boundary. Let the approach slab to be 400 or 4500 millimeters, and when we finish we can press on apply. The span direction is not placed, so we press on span direction and we select one of the boundaries and we press on finish. Now we can go to the section, we get back all the elements, we select this slab or approach slab and move it to the top over the corbel. Then we go to 3D view, we can select this approach slab. Then we press on modify sub element. We can adjust the slope for this direction to apply the super elevation. Then we can apply a certain distance for this side. Let it be 400 millimeters. Let us visualize this approach slab location and the placement. Then we go to the site plan, we select the approach slab and we press on mirror to have it from the other side. In this way we have most of the element for this bridge. We still need to put the barriers. Now we go to beam from structural palette, we press on 3D snapping. We adjust from the properties palette the value of Z justification to be bottom, and we press on the edges of the bridge starting from the abutment to the deck to the last abutment. Then we select all these barriers, we press on mirror, we remove the copy and we press on one of the faces. Then we adjust this offset to be minus 25 millimeters. And now we need to make the same exercise from the other side. We can press on the beam and using 3D snapping also and pick lines starting from the abutment to the last abutment. Then we select these barriers and we press on mirror to this face. Then we adjust the same offset to be minus 25 millimeters. Now let us go to the site plan and then to the section. Let us reduce the view range. Go to view, make it shaded to see exactly how is the section of this bridge, so everything is correct. Now we can visualize our bridge from all sides. We can go also to the longitudinal section. Let us adjust the crop view a little bit to see all the bridge, make it shaded. The location of section is not showing the pier. We can adjust it a little bit to see the pier. Still the pier doesn't appear, so we have to move it down to cut the pier. So now all the elements are shown in the section. Here we arrive to the end of our session. We hope that you enjoyed creating this bridge. Please, at the end of this video, we need a rating from your side to support us by 5 stars.